Okay, we're on a chapter of combinations, and they've asked us the main difference between a combination of 3 out of 7, right? That was our combination. So 3 out of 7 in a combination form versus as a permutation. Well, we know there's a major difference in the formulas. Our combination formula is n factorial divided by n subtract r factorial times r factorial, where in the other one they're missing that r factorial for the permutation. Okay, so first off, n represents which of the terms, the 3 or the 7? Okay, so in other words, this says a combination of 7, and our r represents 3. Is that the same for permutation?
Yes.
Yeah. Okay, good. So we got that. And then our n factorial. Well, since n is our 7, we have 7 factorial over 7 subtract 3 factorial times 7 factorial. In our permutation, we have 7 factorial divide 7 minus 3 factorial. Now, what I'm going to do in this one is I'm actually going to break this up so you can see how this simplifies a little. Okay? So we have our combination and our permutation here. So this will be our combination, permutation. C and P, we'll call it. Okay, so what this actually reads is, we'll fix the combination one more time so that it's just terms. Combination of 7 and 3 is equal to 7 factorial over 4 factorial times 7 factorial. You okay with that?
Yep.
And the permutation is 7 factorial over 4 factorial. Okay, so what this means is, when we go to fill this out, did we get our combination right in that formula? Yeah? Okay. So what this means is 7 factorial is essentially 7 by 6 by 5, 4, 3, 2, and 1, right? So the same thing over here, our 7 factorial is the exact same. It's essentially multiplying all the numbers of 7, all the integers from 7 to 1, right? So when it's divided by something, what essentially happens is we're able to make it a simpler question. 4 factorial is from 4 to 1. 4, 3, 2, and 1, right? So that's supposed to be number 1. Well, when we have a division like this, we can essentially cancel out terms that are the same. So 1, 2, 3, and 4 cancels out. So really, the permutation of 7 to 3 is the equivalent of 7 by 6 by 5. That would be our answer, and we'd end up figuring that out. Or in this one here, we've done 7 factorial. Now what we have here is 4 and 7 factorial. Okay? So what those mean are 4 by 3 by 2 by 1 by, again, 7, 6, 5, 4, 3, 2, 1. Okay, and I just want to quickly take a look at something because I knew this wasn't right. This is going to become a big factor. The R term is not 7. It's what?
3.
It's 3. So if we should be times 3 factorial. So this should read 4 times 3 factorial, which means the bottom of this is not from 7 to 1. And I knew this wasn't going to make sense because it's going to give us a very large fraction. I made an error there. This should be by 3 by 2 by 1. Okay? So when we go to cancel things out here, well, we have a 1, a 2, a 3, and a 4. So now what we're left with for this combination of 7 and 3, 7 by 6 by 5 on top, but underneath we still have 3 by 2 by 1. So it's going to be a smaller number. So in the end, what are we going to get? 210 over here. Now this becomes 210 divided 6, I think, right? Which is going to give us 335. Yep. There we go. So a very different number from the permutation to the combination answer. Okay, algebraically we have very different things here. Okay, so we saw the algebraic difference between these, right? We looked on our other page here. An algebraic difference, we have quite different numbers, right? The permutation gives us 210 options, where the combination only gives us 35 options. Well, when would the difference actually happen when reading a question? So we go into this question here. Again, we're going to also be working with 3 out of 7, same numbers as before, but our two options are A and B. One is choosing 3 books out of 7. Okay, so just to give you a visual on this, yeah, let's just think of it like this. Here's 1, 2, 3, 4, 5, 6, 7. So we have 7 books, right? There's choosing. We're just going to choose 3. Well, let's say we take the first 3. Well, there's one combination, right? Well, what if I rearrange it and I put this book over here, this book over here, and this book over here, and I chose the first 3? Did it change the 3 books I've moved? No. So the order of them is not important. So because the order is not important, what ends up happening is we use a combination because there's redundancies, right? If I choose book 1, 4 and 7, that's one option again, so let's call that our second option. But then if I decide, okay, well, then I'm going to choose books 7, 4, and 1. Well, I chose the same 3 books. So there's redundancies, and that's when a combination comes into play. Combination of being 3 and 7, which means there's really only 35 options this way. There's only 35 ways we can choose 7 or 3 of 7 books. Okay? But with that same idea, if we've taken 1, 2, 4, 5, 6, 7. Okay, 3 of the most popular books. Well, 3 of the most popular, and we should really specify ranging, from 1, 2, and 3. Ranging first, second, and third. Okay. In other words, implying that maybe the first book in this series is the most popular, then the second book is, and then the third book is. Well, that's one way of doing it. But what if the first book was the second most popular, this was the third, and this was the first? I'm still using those same 3 books, but this is a different way of setting it up, right? So that becomes a second combination. So what ends up happening is I can use the same 3 books in several different ways, which means I'm going to have many more options, and that's where a permutation comes in which case we're going to have 210 options, which we solved algebraically. Okay, so that's just the difference between those two. Does that one kind of make sense? Yeah. So that's